Hello everyone, it's Kevin, and welcome back to another Moonbeam Deep Dive. Thank you so much for joining me today. I'm excited to take you through Hardhat in great detail. This will be a full tutorial. We'll take you through step-by-step getting started with Hardhat, installing it, and then we'll move on to compiling smart contracts, deploying smart contracts, verifying them, and then of course testing them as well. So without further ado, let's go ahead and get started. So today we'll loosely be following along with one of the tutorials on the Docs site, and you can find it here under the tutorials section, and then head over to Ethereum API. And you'll find it underneath the section Get Started with Smart Contracts. All of the steps we're taking in the video are available on the written tutorial. So if you prefer one or the other, feel free to stick around here. If you prefer to go out and try it yourself with the written tutorial, you can go ahead and do that too. So there are a couple of prereqs. You do need to have a funded account with Moonbase Alpha Dev tokens, preferably 2. You also do need to have a Moonscan API key. That's very easy to get. You can follow the instructions here if you don't already have it. But essentially, you'll just sign up on moonscan.io. You'll be able to get an API key, and that API key works for both the Moonbeam network and the Moonbase Alpha network. If you'd like to get an API key for Moon River, that requires a different API key, but the Moonbeam one works for both mainnet and testnet. So I've got that prereq. If you don't, go ahead and get it. You can ignore this step about the Moonbeam local node. We will be skipping that today just for simplicity. Instead, we'll be using Moonbase Alpha. It mentions here the endpoints section. You don't need to worry about this either. We'll be using a public RPC endpoint that we're going to define in our Hardhat config. So let's go ahead and get started in our terminal with installing Hardhat and getting a project directory set up. So let me provide just a little bit of background about the contract that we're going to be building today, because today we're going to go beyond just doing a simple hello world or doing a simple storage or a simple incrementer contract. We're going to have a contract that's actually quite complex, and it's quite fun though. So the contract that we're going to have is a staking DAO contract, and Moonbeam, as you know, has a full staking palette, and it also has a staking precompile. So that means that you can go ahead and stake in the UI here at apps.moonbeam.network. You can go ahead, select a collator, choose the amount that you want to stake, and then bam, go ahead and stake that way. You can also use the staking precompile, which is a Solidity interface that allows you to call the functions that are available here, and these will in turn go ahead and stake tokens for you. And you can call this from either another smart contract, which is very cool, or you can call it just from a typical web application. And that's what this web app is doing right here, is it's calling the functions of the staking precompile. Now, one of the requirements of Moonbeam's staking palette is that you do need to have a minimum amount to stake, and that minimum is at the very lowest 50 glimmer. But the way that the staking palette works is that you need to select a particular collator to delegate to, and those particular collators have their own minimums, and this is because each one supports up to 300 different delegators. So if you have less than 300, then the 50 limit can stay intact, but if you have more, then that limit starts to gradually creep upwards. And so as you'll see here, with my delegation here, I have only 51 glimmer, but that's not quite enough to be in the collator's top 300, and so I need a minimum here of 63.98, it looks like. So of course I can go and I can stake more, but for our example, it makes it's more fun for us to instead create this staking DAO, and the staking DAO is going to make it so that you can have multiple delegators come together, and once they're going to pool their funds, and once they have enough, that will go ahead and actually delegate on their behalf. And of course, they'll be able to get those rewards. Everything will work kind of exactly the same, except they'll be below the minimum amount. And of course, this would require that I'm going to put these funds in, and then we'll need to get more in order to actually delegate. Now, we'll be doing the activities today on testnet, and that is, of course, recommended to do on testnet rather than mainnet. I was just showing here mainnet just as a demonstration, but everything we do today will be on the Moonbase Alpha testnet. So let's get back to creating our project structure and installing Hardhat. So the first thing we'll do, we'll just create a directory for our staking DAO project, and we will go ahead and run npm init-y. The -y just short circuits a confirmation. We also want to install Hardhat. So let's go ahead and do that. This will install Hardhat locally. It's not recommended that you install Hardhat globally, just because you might want to tweak the parameters for each project that you have. So we're installing Hardhat locally, and then we're going to go ahead and run npx hardhat init to go through the Hardhat starter project workflow. You have a bunch of different options here. We're going to choose create an empty Hardhat config. That's actually the simplest, and we are heading right along. So we are going to create a directory for our contracts folder. Let's go ahead and do that. We're also going to create our contract of delegation DAO.sol. So you can run these commands, and we can also go ahead and open up these files in a Finder window. So let's go ahead and do that. Let's open them up. Here we have staking DAO. Let's make it a little easier to see, hopefully. Okay. So we're going to copy the contents of stakingdao.sol. And I'm not going to run, actually, let's simplify it a little bit here. Let's go ahead and open up delegation.dao.sol. And we have the nice formatting here. So I don't want to go through every single minute detail of the contract, but I do want to give some background on what it's doing in general, and how this works, right? So delegation DAO here is a DAO, as we mentioned, and it needs to keep track of a couple different things. It needs to keep track of its own state, whether the DAO itself is collecting funds and preparing to stake, whether it's actively staking, whether it is currently revoking a delegation, or whether it has been completely revoked. So the DAO needs to keep track of the state. It also needs to keep track of its members, and it needs to keep track of how much stake each member has put in. It also has a total stake variable. It needs to enforce a minimum for the protocol. And this minimum here for the protocol, this is the threshold at which it will go ahead and attempt to actually delegate. So we have it set here to 5 Ether. This is corresponding to the minimum on Moonbase Alpha. Moonbase Alpha has a minimum delegation amount of 5 dev. So that is lower than the one on mainnet. Mainnet has a 50 Glimmer minimum. But again, we're going to be doing everything today on testnet, so this is perfectly fine. We also have the address for the Moonbeam staking precompile. If you don't know what the address is, there are 2 places where you can find it. So the first place you can find it is here on staking interface. We always put the address in the comments. So you can find that here. And another place is just if you're looking on the Moonbeam Docs site, you can also find it here, of course, underneath the staking precompile page. So that's another place that you can find it if you're unsure. We also have a target for the DAO. So the DAO needs to choose a particular collator to delegate its funds to. In this case, we need to keep track of that. And this is also going to come into play with our tests, because we want to make sure that the DAO is properly keeping track of whoever it's going to delegate to. We have some events to keep track of deposits and withdrawals. And in our constructor, when we set up our DAO, we need to pick a target. This is the collator that we want the DAO to delegate to. We also need to choose an admin when we create the DAO. So we'll take care of both of those things upon creating our DAO. And when we do that, we'll just set the address of the deployer as our admin. And of course, we have an initial state. We do have some functions here to help manage membership. So we need to be able to create new admins. We need to be able to create new members, or essentially grant membership to new people. And this is important because we only want you to be able to interact with the DAO if you're a member. Here we have an add stake function. We also have a withdraw function. We need folks to be able to take out their funds. And we also need the DAO to be able to manage its activities like revoke its delegation. And this can only be called here by the admin. Now, I don't want to get too much into all the detail here because this is a workshop about Hardhat, but I just thought that this would provide some clarity on what we're doing with delegation DAO. And there's some other functions here like changing the target of the DAO. So let's go back. Let's go back here. And another thing, because we are going to be interacting with staking interface, rather because the delegation DAO is going to be calling the functions of the staking precompile, we need to load that interface into our Hardhat environment so that we know the functions that we can call, and so that the proper API can be generated and all that. So let's go ahead and create that now. We'll head back to our text editor here and go ahead and copy the contents of stakinginterface.sol. And again, stakinginterface.sol, this is a precompile, and this is allowing you to access substrate functionality. So the staking palette is part of Moonbeam's substrate offerings, and the precompile allows you to access it from the EVM. There are many more precompiles that Moonbeam has. This is just the one that we'll be talking about today. So for more information about Moonbeam's precompiles, you can find them, of course, on the Moonbeam Docs site. We have an entire section devoted to all of the different precompiles that Moonbeam offers. So be sure to check those out for more info. Okay, and one more thing that we need. We are using a couple of Open Zeppelin contracts in Delegation DAO. We're using access control as well as address. So we need to make sure that that is installed. Okay. Next, we need to set up some bits in our Hardhat configuration file. We also need to install the Hardhat toolbox. So let's go ahead and get that done. Cool. So we've got those installed. And we're going to be interacting with Moonbase Alpha today, so we can use this public RPC URL. That's just fine. If you're interacting with Moonbeam, you can go ahead and use one of the public endpoints as well, or your own dedicated endpoint. That is just fine. So go ahead and copy the contents here of Hardhat config, and we can overwrite the existing content that's in there. Now you'll see a couple different private keys loaded up here. This is for a local Moonbeam node. We're not going to be using that today. Instead, we need to put in some private key information here for our accounts in Moonbase Alpha. Now remember, never store your private key here in a JavaScript file. This is purely for demonstration purposes. I have 2 accounts that I've funded, and so I'm going to put those private keys in right here. I funded them with dev tokens. They've got 10 dev tokens each. If you don't have funds, you can go to faucet.moonbeam.network and you can go ahead and get some as well. At a later step, I'll put in my Moonscan API key, but we don't need to do that right now. Cool, so make sure you've saved it, and let's head back here. And let's go ahead and compile the contract. We'll run npx hardhat compile. Oh, sorry about that. My private key got cut off, so let me fix that. Okay, now let's go ahead and compile it. Cool, and it's looking good. So next we want to, of course, deploy our contract onto Moonbase Alpha. We also want to run some tests. So we can first run a couple different tests, and then we will run our deployment, and then we'll do the verification step. So I know there's a lot going on. If you need to take a quick pause, take a quick break, that's totally fine. Otherwise, we will go ahead and keep going. So let's talk a little bit about our tests and what we want to test and how the testing is going to work. So typically, we might use a local node for testing. You can spin up a local Moonbeam node using Docker or by compiling the binary. You have accounts that come pre-funded with lots of tokens on this account. But for the purposes of demonstration today, because we're going to be demonstrating the verification step, I figured it would make sense to do everything on Moonbase Alpha so that we're not switching back and forth between networks. So let's skip down here to our DAO.js file. And this is our test file, and this is going to include everything that we need. So let's first create the file. Let's create a directory called tests, and we will create a file called DAO.js. So we can do that. We can say tests/DAO.js, and we can come back to our text editor, and let's paste in the DAO.js file right here. Now, a couple things. We will be using ethers. We'll be using some of the assertion functions of chai. We'll also be redefining, just for simplicity purposes here, the same two private keys that we had specified earlier. So let me actually go ahead and copy these in. Copy these in here as well. And these are the same ones that we had in our Hardhat config. They match perfectly. Now you can also import them from your Hardhat config, but for demonstration purposes, we're just defining them here so that we can more easily manipulate them. And of course, we want to define the target collator that we want the DAO to delegate to. Okay, so within our test file, we are going to deploy a DAO, and we are going to specify a target collator. That's the first parameter. And the second parameter is just the admin. So that's going to be the deployer. And then we have a little bit of logging here. So if we have any errors, if you have a problem, hopefully it can be a little bit more easy to identify and then sort it out and solve it. Now, our first test case here is going to make sure that the DAO stores the correct address of the target collator. So when the DAO is created, it's going to store a target collator here. It's going to store this one. We want to make sure that the DAO holds on to that, keeps it. And so when we go back and ask it, we want to make sure that it's the same one. And so that's all we're checking here in this assertion, is that it does stay the same. We also have a test case here to check that the DAO has 0 funds at inception. If it has a non-zero number, that would be a problem, because it would throw off our math and cause problems down the line. Our third test case is we want to check that non-admins cannot grant membership. Only members should only be granted access by admins. So if we have a non-admin trying to grant membership, it should fail, and that's what we're going to be checking. We expect that the transaction should be reverted. So it'll succeed if this reverts. Okay, and our last test case here. Only members should be allowed to access member-only functions. So one of the member-only functions is to check the free balance, and we expect that this transaction will not be reverted. We also expect them to have a balance of 0. That last part's not as important. We basically just want to make sure that if we grant them membership, which we do here, we have the admin granting them membership status. Once they're a member, we want them to be able to call the member-only functions. Cool, so that's it for test cases. Let's go ahead and run it. So we can run it with the following command. We can run npx hardhat test -- network, and we will use the Moonbase network. The network names are defined as they are in your Hardhat config. So if you have different names here, you'll just have to use a different command. And we also want to specify here the name of the file that we want to run. So we'll say tests.dao/js. And because we are running this on Moonbase Alpha, it may take a little bit of time. It may take 15, 20 seconds per transaction. Each test requires a different transaction, and it requires each transaction to be confirmed and to be showing confirmed status. So that's why it can take a little bit longer than a typical transaction. So we do have 2 errors. As you can see, we have a timeout error. That's easy to fix. That's not a problem. The second one is deployed DAO.getTarget is not a function. So I use this getTarget here, which we actually don't have that getter. So let's go ahead and define a simple getTarget function here. This is going to return back the address, and it's going to return back the target address, which is stored right here. Cool. So we'll save it. When we save it, we can go ahead and run npx hardhat clean and npx hardhat compile. And now we can go ahead and run our test case again. Cool, and everything passed. So let's go ahead and head back to our tutorial. And in the last steps, we want to demonstrate deploying to Moonbase Alpha as well as verifying on Moonbase Alpha. So in our test cases, we did use Moonbase Alpha, so we already have a deployment here, but we'll be doing another one. So we'll be using Hardhat Ignition, which is a new way to manage deployments, and it makes it easy to handle recurring tasks surrounding deployments. So Hardhat Ignition is quite cool, and we'll show you how to get started with Hardhat Ignition. So all we need to do is we need to import it, of course. We need to define a Hardhat module here. We need to define a build module. We need to go ahead and set our parameters. So we need a target collator. We are going to define an account that it's going to be coming from, so the deployer account, and that's going to end up being the admin. And lastly, we just return an object to the caller, and this can be used to interact with the deployed contract. So that's it. So it's only a couple lines of code, and it's quite fast, and it makes it easy when we want to verify. Verifying our contract is actually just a single line, but it's not like some crazy long line where we need to define a bunch of things. It uses the information in our module here in order to verify the smart contract. So all we need to say when we want to verify is basically just Hardhat Ignition verify. It's quite easy. So let's go ahead and create a new file. And if we head into our Ignition folder, we'll open up Delegation DAO, and let's copy the contents here. We'll save it. And let's go ahead and run this command. So this command, npx hardhat ignition deploy, we are going to define the path to delegation.dao.js, which is this file right here. We're going to define the network that we want to deploy to. In this case, we're using Moonbase. And lastly, we have a deployment ID here. Now, this is optional. You don't need to provide a deployment ID, but it's essentially just a name for your deployment. So we can call it tutorial, you can call it your name, you can call it whatever you want. But that's going to make it very easy when we run the verify command. So include a name here. You can call it whatever you'd like to call it. So instead of your name here, I'm just going to call it tutorial. And let me just adjust this a little bit so we can see everything. It's going to ask you to confirm the chain ID you'd like to deploy to. Moonbase Alpha has a chain ID, of course, of 1287. Cool, and our contract was deployed. You have the address here of the contract, and if you'd like, we can go ahead and look that up. So let's go to moonbase.moonscan, paste in the contract address, and we can see it was deployed. We can also see that it hasn't been verified yet. So let's go ahead and verify. And verification is so easy. All we need to do is say npx hardhat ignition verify and the name that you just provided. In our case, we provided the name tutorial. Now remember, you do need to have an API key for Moonscan defined in your Hardhat config. So I'm going to go ahead and do that, and you can find that here by going to moonscan.io. We can actually find that here. I'm already logged in, and I'm going to go ahead and copy my API key. So I'll save it, and we are just going to run npx hardhat ignition verify, the name that you defined in the last step, which I defined it as tutorial. So let's go ahead and do that. Cool, and our contract was verified. And to double check that, we can head to the link here, and we should see a check mark, which we do. It was verified. Great, and that was easy. It is a lot easier to verify via tools like Hardhat, typically than going through the user interface, especially because if you have multiple different libraries or multiple smart contracts that you're interacting with, it's way easier to manage those from a tool like Hardhat and to verify it from Hardhat versus trying to flatten all those contracts and get them all into one file and then upload it through the UI. So I highly recommend verifying your contracts through a manner like Hardhat. Now this tutorial does go on, and it'll go through the steps for deploying to Moonbeam Mainnet. It's the exact same steps that we did for Moonbase Alpha, just for Mainnet, and the same thing for verifying your smart contracts. Thank you so much for watching this tutorial. Be sure to stay tuned. We're going to have more different tutorials like this, where we take a little bit more of a relaxed pace. We don't cram everything into 5 minutes, and we go through some things in more detail. Thank you so much for joining us.